So let's discuss a problem from GATE 2021 physics, and this is from the quantum mechanics, and it is related to the first Born approximation, spherical potential, and scattering amplitude for that. So here's the problem. So consider the potential U of R defined as, so this is the potential given, u of r is equals to minus u naught e power minus alpha r by r. So this is the form of spherical potential, so where alpha and u naught are real constants of appropriate dimensions, so they are having their own appropriate dimensions, such that finally we would get the dimensions of u of r like that. So according to the first Born approximation, the elastic scattering amplitude calculated with u of r for a wave vector momentum transfer q. So this is the momentum transfer, which is nothing but k minus k dash. So and alpha tends to 0 is proportional to, so alpha tends to 0. So here what we need to find is elastic scattering amplitude calculated with u of r with momentum transfer q and alpha tends to 0 is proportional to, that one we need to find out. And they have given us some useful integral in the process of calculation. So let's have a look. So from the first Born approximation for spherically symmetric potential, so for the uh, spherically symmetric potential, and for the Born approximations formula for the scattering amplitude is this. So f of theta is also minus 2 mu by h cut square q integration of 0 to infinity r dash v of r dash sine of q r dash into dr dash. So this is the form. So here mu is nothing but the reduced mass of the system, so 0 to infinity r dash v of r dash. So this is the scattering amplitude formula. So now as the potential was given in the question, so this was the potential, so that one we need to substitute in here. So on substituting that, u is u naught, that means in the place of this u naught into e power minus alpha r by r. So this is the potential given, and remaining terms as usual. So instead of r dash we are just taking r, simple. So for simplicity taking r. So here minus could be taken out. So finally what happens is minus into minus plus would become, and 2 mu, and here u naught is a constant and r would get cancelled. So finally we would have 2 mu u0, and that means u naught like that, by h cut square into q. So this is the constant, and what would remain inside the integral is this. So finally this e power minus alpha r and sine of qr, this would remain inside the integral. Now we need to solve this integral, but it was given as a hint. Sine of qr e power minus alpha r dr is equal to q by alpha square plus q square. So we could apply, so this is the integral, so they have already given. So but if we want to calculate it, we can calculate by making use of the, we can use the formula e power ax sine bx formula like that. So if we can remember this formula, so for this some particular formula you will be having, or else you can just solve it simply by using uv formula. So here we all know that this is the uv formula. Integration of uv dx is nothing but u into integration of v dx minus integration of d by dx of u into integration of v dx whole dx. So we could make use of this formula. So what so this is the integral we need to find out. So let it be I is equals to 0 to infinity sine of qr e power minus alpha r dr. So for the ease of calculation we need to assume this to be I. So now if we apply uv formula, this is u and this is v. We need to follow the Euler rule here: inverse, logarithmic, algebraic, trigonometric and exponential. So we need to give first priority to trigonometric, then the exponential function. So now on applying that formula, u into integration of v dx, that means integration of e power minus alpha r is nothing but e power minus alpha r by minus alpha. So again applying limits, and next minus integration of d by dx of u. So that is nothing but, so this is nothing but u. The differentiation of sine theta, differentiation of sine theta is nothing but cos theta. So here we are having that means differentiation of sine ax is with respect to x is nothing but as cos ax. So here this is a constant, q into r is there. So differentiating sine qr with respect to r, what we will get, cos qr into q, which is a constant, q into r. According if we consider in the case of in terms of variable of r. And next integration of v dx is nothing but this only, integration of e power minus alpha r is nothing but e power minus alpha r by minus alpha. That means in integration of e power ax is nothing but e power ax by a, like that. So the in the place of a we are having minus alpha. So now we need to calculate this. So if we apply limits over here, what would happen is, if we apply for this entire function, if we apply upper limit, that is infinity, so what we would get, so e power minus infinity we would get. That means nothing but e power minus infinity is nothing but 1 by the e power infinity. So 1 by infinity, so 1 by infinity is nothing but 0. So upper limit would be 0. And next if we consider the lower limit, sine 0 would be 0. Sine 0 is nothing but 0. So that is also 0. So here this term would get neglected, because both the terms were, after applying the limits, we are getting 0. Next this is remaining. So now we need to solve this. So here already one minus is there, here also minus is there, so minus into minus plus, and q by alpha are the constants, so it has been taken out. So now next again we need to integrate this term. Here in the place of sin x, we are sin qr, we are having cos qr. So again, so like that, again if we do integration, we would get the same term finally, sin qr. That's why we need to imagine this I here. So let's see what happens here. So here u is this and v is this. So u into integration of v dx, that is nothing but e power minus alpha r by minus alpha, that is taking limits going from 0 to infinity. And next minus integration of d by dx of u, this term d by dx of cos theta is nothing but minus sin theta, this is something but minus sin qr into q would remain. And next integration of v dx is nothing but integration of e power minus alpha r is nothing but e power minus alpha r by minus alpha. So finally this minus would get cancelled, minus and minus is nothing but plus. So here finally minus would be remaining, and this sin qr into e power minus alpha r dr. So if we solve this, so here again if we apply the limits for this term, so on applying upper limit it would become 0. That means e power minus infinity, that is nothing but 1 by infinity 0. Now next if we apply the lower limit, that means cos 0 1, e power 0 is also 1. So this would stay this time. So actually it is upper limit minus lower limit. So here what we are getting, cos 0 e power 0 1 minus alpha 1 by alpha on applying the lower limit. So minus 1 by alpha we are getting, that is nothing upper limit minus lower limit, so minus into minus plus, so 1 by alpha. And here this minus would go off, and q by alpha is a constant, it has to be taken out. And as we are doing integration with respect to r, so next inside what would remain is sin qr e power minus alpha r. So this is the remaining term. So if we clearly observe, this term is same as the integral which we have taken before, as now we have discussed. So in this place we can replace it with I, just for calculation. Otherwise if we go on doing integration, the process repeats itself. So better to use this I notation. So in the play now here it is replaced with I. So now sending this entire term to that side, it would become plus q square by alpha square into I. Now if we just simplify by taking out the LCMs, so into alpha square by alpha square here. So finally it would become alpha square plus q square divided by alpha square into I. Alpha square would get cancelled. So finally I is equals to, on sending this term to that side, q by alpha square plus q square. So this is the integration. So this was the thing given in the form of hint. So if it were not given, the calculation process is this. So simply what we can do, just place this in this formula, that is this. So actually we have calculated this term now. So now we need, in the place of this, we need to replace it with what we have got the result. So that one we have replaced in that formula. So here q would get cancelled. And another important thing is they have also mentioned alpha tends to infinity in the question. So here it was mentioned q is the momentum transfer and alpha tends to 0. So that is nothing but limit of alpha tends to 0. So in the place of alpha we need to replace it with 0. So 0 plus q square. So finally what we would have, this term 2 mu 0 2 mu u naught by h cut square into q square. Only this one would remain here on this. So finally they have asked us about the proportionality between this scattering amplitude and this momentum transfer q. So finally if these are all, if these all are taken to be constants, so finally what would remain is 1 by q square, k into k by q square. That means f of theta is proportional to 1 by q square. That means it is inversely proportional to q square. That means directly proportional to q power minus 2, like that. So this is the answer for this question. So q power minus 2. So the final calculated scattering amplitude is proportional to q power minus 2. So this is the problem. So thank you.